Welcome to Intel on AI, the podcast that connects leaders with listeners. My name is Heather McGuigan, and I am your host. Today's guest is Ray Peng. Ray Peng is the Senior Vice President, Technology and Enablement at Supermicro, a global leader in high-performance server technology, which continues to expand its footprint in the AI, cloud, storage, and 5G edge markets with its innovative server solutions. Ray has been a key speaker at international events, highlighting the importance of green computing and Supermicro's commitment to sustainability. The company actively collaborates with partners, customers, and the community to promote awareness and drive positive change on a global scale. Ray Peng, welcome to Intel on AI.
Thank you, Heather. My pleasure. Thank you for the introduction.
It's all you. It sounds impressive when it all comes together, doesn't it? We've got a great conversation today where we're going to be weaving in all of the different areas that that Supermicro and your desires come together to help throughout the world. First, I wanted to ask if you would explain a little more about Supermicro as the company and what its endeavors are around the world.
Oh, absolutely. So Supermicro actually is a US-based company founded in 1993, right in the heart of Silicon Valley. Since the founding of the company, San Jose has always been our headquarters and where our main R&D and lots of our engineers are based. But the company also expanded into Taiwan in 1996 and also in Europe, in BV, in 1998. So today, we're a global company doing business in over 100 countries. But we still have our main footprint in the United States.
Amazing. So your and Supermicro's slogan is, "We keep IT green." How does sustainability actually show up in your AI and server infrastructure work?
You know, the theme of the Earth Day this year is our power, our planet. Because since the ChatGPT moment, if you will, just 2.5 years ago, the power demand for global data center has just accelerated, exponentially. The demand for energy is just insatiable, right? I give you some numbers. There's some announcement from OpenAI. They're trying to build a Stargate AI infrastructure that will require 5 gigawatts of energy, right? Just give you some reference point. The city of Los Angeles consumes about 2.5 gigawatts. And that's a 4 million people city. One data center going forward is going to 5 gigawatts. And that demand is just going to continue to grow. So how do we create clean energy and also create energy efficient AI infrastructure is really critical. That's why the work we do at Supermicro, creating green computing, these energy efficient servers, is going to be really critical to a green and sustainable future going forward. I want to tell you some background on why Supermicro has been doing green computing pretty much since the inception of the company. So to talk about that, I have to talk about my boss, Charles Liang, who founded the company 31 years ago. Charles hails from southwest of Taiwan, from a very beautiful mountain area. So when he was a kid, he actually walked down the mountain because his family lived on a mountain. He has to go down the mountain, go to school for an hour. And after he finished school, he has to go back the mountain, spend another hour. So during his, during his childhood, he pretty much spent lots of time in the green environment. So he has a passion for this, how to preserve the Mother Earth. Okay. So when he founded the company, green computing has been in our DNA since the inception. So we have been doing that for decades. And the last year, we lead the deployment of DLC deployment, the largest DLC cluster in the world. Again, further saves energy and improves the efficiency of the AI computing infrastructure. So there's lots of stuff that we do at Supermicro that will improve, have a better AI infrastructure and a better positive impact on the environment.
And I think the average person does have a very tangible understanding of environmental sustainability when it comes to a coffee cup or using plastic or taking the bus a little more. These are really concepts where we see that sort of direct action, but I don't think we're quite sinking in about this energy consumption that you're talking about and how much it's going to affect our future.
Yeah, actually, I want to talk. This is a very very interesting question. I want to kind of look at a few different trends in the industry and see how we can connect the different dots. Right. If you look at the AI infrastructure space over the past few years, the accelerations, the pace is just so furious, right? But why is this happening? We all know that the AI requires lots of compute, and ChatGPT basically tells people, you can do lots of amazing things with all this AI model and all this AI training. But actually, before ChatGPT, there's a landmark paper released by Google called the Transformer-Based Architecture for Deep Learning, titled Attention is All You Need. So today, all the AI models we are talking about, no matter whose foundation model, whether it's the Grok from xAI, the ChatGPT, the Cloud, the Mistral, they're all based on Transformer. Okay, Transformer-based model is fantastic, but it has something called this quadratic scaling effect. What that means is when you're trying to build a larger model, when you're trying to have larger, longer data input, the compute and the memory requirement just quadruple. If you double your input or you double your model size, your compute and memory requirement basically just squared or quadruple. So what this means is, as people build larger and larger models, in order to gain more insights and get better results, the computer requirements just going through the roof. That's why over the past few years, you see the demand for GPUs for compute is just literally just insatiable. Okay, so I think as long as the transformer-based model is the dominant AI architecture, the demand for compute is going to continue to grow. So what that means is the demand for data center power is also going to continue to grow.
I want to talk specifically moving into the science world. And we sort of talked about melding all of our different aspects of our life together and how AI and green computing is going to influence each of them. But I want to talk about the artificial boundaries that exist specifically between scientific disciplines. What excites you most about the shift into, as a lot of people are now saying, one big science?
Yeah, let's. If you think about it, right, the nature that we're living in on the Mother Earth is not segmented by physics, chemistry, biology. It's basically one physical environment, nature we are living in, right? So I think this when we do AI research, trying to discover the natural phenomena, it makes sense, right? To have cross-disciplinary research that basically looking at the phenomena or the problem holistically, right? I think going forward, I think it's probably just one science that we are trying to study.
Can you think about one sort of specific instance right now where those boundaries are dropping?
Yeah, for example, right? I think if you look back just last year, the Nobel Prize was awarded to the AI model, the AlphaFold from DeepMind at Google. Okay, so that's really a cross discipline from AI, computing and protein 3D structure research, and the results is amazing, right? The results is you have AI model that can predict the 3D protein structure. And if you think about how research was done in the past, you can have a PhD student, super smart PhD student, studying maybe one or several proteins for their entire PhD thesis, 5-6 years. But there are many, many billions of proteins out there in the nature. So in order to study all those proteins, as many proteins as possible, we need AI, we need AI agents, we need to basically do a holistic research on all of them. So we know all the secrets and how we can discover new rules, I guess, new laws, and help us make live better.
Very, very cool. Thank you for answering that. It's really fascinating. And you kind of were able to go, oh yeah, they just did it on a really, really grand scale that is going to affect all manners of scientific research around the world.
If you think about the weather forecasting, right? People have been doing weather forecasting for a very long time, right? But today, weather forecasting can be very accurate, and also can forecast a few weeks ahead of time, right? So what is weather forecasting? It's really trying to predict what's going to happen in the future, right? But besides weather forecasting, how about we expand that same approach to other areas, like predicting things that might happen in the future so we can prevent certain things today, right? Basically do more simulations using AI, using data, right? And that can be applied to healthcare, right? So to prevent certain disease or problems developing, and can prevent traffic jams and prevent, certain, bad things from happening. I think there's so much things we can do. Going back to your one big science and also, this what AI can do, right, across disciplines. So it's very exciting. We live in such exciting time.
I want to move over into the topic of Gen AI. And as we see the advancement of AI in general, this is now becoming a much more standard conversation. So we're seeing a surge in enterprises that are racing to implement Gen AI. What are some of the smartest ways that you've seen organizations get real ROI from AI?
Yeah, there are there are so many cases, right? I think as enterprise start adopting AI across different verticals, right, in the financial services to do fraud prevention and detection, in the retail, helping basically checking the inventory in real time, make sure at the point of sales, whatever customer need is always available. And from if you're in a legal space, right, how do you do case study and read through all the case studies using AI instead of human reading through all the paperwork? There are there's so many use cases. It's just I think it's very exciting.
The first thing I heard of when I thought about a lawyer sort of trying to read cases, I thought, wow, they might get some sleep sometimes. That would be nice. If the research goes a little bit quicker, it kind of puts everybody at a moment to get a little more rest when people are just feeling like we're going nonstop right now.
Yeah. I know. I mean, all the, even for Supermicro, right? We started adopting this AI in our workflow, right? For example, Supermicro has very broad product portfolio, huge, right? We have lots of menus, we have lots of knowledge, we have lots of information. For customer who's looking for those information, whether from customer support perspective or from sales perspective, we have something called Super GPT that can basically give our internal folks as well as customers answer really quick, right? In a real time, almost in real time manner. So it's I think enterprise AI is going to have a huge and bright future. I think we're going to see continued adoption, accelerate adoption from this point on.
Do you have a specific portfolio or genre within Supermicro that you're more keen on?
Yeah, for me, I think the healthcare is a huge area that my team and I spend time on. Just trying to see how you can basically marry AI with the current healthcare pharma drug discovery research. I think those are very key verticals that myself and my team are kind of spending time, right? FSIs and other financial services, even federal space, right? So there are lots of different verticals that are, I think, at the beginning of adopting some of the latest agentic AI workflows.
And it's exciting to create some of those partnerships. And you have worked with a wide range of partners, including Intel. How do strong partnerships accelerate innovation in AI infrastructure?
Yeah, that's I'm going to try to answer this from a few different angles, right?
Good.
First, Supermicro is uniquely positioned to work closely with all the key partners, including Intel and some other key technology partners in the Valley. Okay, so we are 10 minutes away from Intel's R&D building, right? We share some campus with Broadcom, right? We are very close to other key technology partners. This is going back to the philosophy of our founder, Charles, right? I tell you some story. When Charles founded Supermicro in 1993, at that time, people started doing outsourcing, right? The outsourcing this engineering to other places, like in Taiwan, in Asia, in some other places. So when Charles founded Supermicro, in that backdrop, people are telling Charles, "You're crazy. You're not wise, because Silicon Valley should start a software company, not a hardware company. Hardware all moving to offshores, to other places." So as a result, when he founded Supermicro, he got zero funding. He started the company with his own money, with his investment from his friends. Okay. But we believe for a true leading edge technology, you need to be in Silicon Valley. You need to be close to the ecosystem, because nobody can do this complicated, advanced design all by yourself. You have to work closely with the partners. You can control the schedule. You can solve the problem quicker. Okay, so that's why we are here. We are still here. We are expanding here. We actually just purchased our third campus in Silicon Valley just a few months ago. We're going to add another 3 million square feet of office space, manufacturing space, because we believe in order to do true cutting edge innovation, you need to work in the ecosystem. You need to work with partners. Okay. So another way to look at this, why you need to work in an ecosystem with different partners, is because today the technology we need to deliver to our customers are so complex. Okay, it involves, for example, right, in order to deliver large-scale AI infrastructure, you need the chips, right? You need to put the chips into a most energy-efficient servers, AI servers, like from Supermicro. But those servers are very dense and also requires a lot of power to run. As a result, it generates lots of heat. So how do you get rid of the heat efficiently? That's where liquid cooling comes in. You need very energy efficient liquid cooling so you can get rid of all the heat. But in order to have
I'm going to ask you about that in a little bit too. You said the magic word. I thought, here comes the cooling. Yeah. I'm gonna get into more detail later.
You see, cooling, also involves a large ecosystem, right? Involves the cold plate, the manifold, the CDUs, put them all together, resolve the tubes, and the validation, and also you need networking. You need to deploy this thing in a data center, all connected together, fully tested. You need the data center to be ready to have the power and also have the cooling capacity. So I'm telling you all these details to tell you how involved and how many partners you need to work together in order to bring to life this kind of a large-scale deployment. So that's why it's critical to work with partners, the best partners, the ecosystem. Again, I give you a long-winded answer, but those are the details.
It's a brilliant answer. No, but it continues to come back to your, to his core environmental belief that everything is connected.
Correct.
And that one surface and one aspect of the world serves another.
That's right. That's why, we did, Supermicro, we have started delivering rack scale total solution for the past few years. So another phenomenon we started seeing over the past few years is it's become a commonplace for customers to order billions dollar worth of AI equipment and infrastructure. I'm talking about billions. Okay. In the past, when you see $1 billion order, it's like rare, right? It almost never happens. But now it's like, people building multiple $1 billion cluster. But when you spend that much money, you want to have your money put to use as quickly as possible. So you want somebody who have the deployment experience, who can put all the AI infrastructure that involves, so many different pieces and connected and tested. So you can use this whole infrastructure to do compute as quickly as possible. Otherwise, you spend billions of dollars, you wait a year, you're not putting money to use. So time to online is a metric we keep very closely. That's something we are really good at delivering to our customers. The shortest time to online.
Yeah, I was a kid of the 80s, so I'm still like amazed by millions. Like it was sort of this year. It was sort of this year, and talking, reading a lot of politics and getting much more comfortable with sort of the billion word. And it was earlier this year that I went like, wow, you kind of like talk about billions now a little more normally, but like I still remember when the concept of $1 million was like, that was wild to me, that's the kind of money that we were spending. And that's the kind of trust and responsibility that the leadership in AI has to take on in order to manage all of our needs.
Yeah. No, I've give you some numbers, right? We talk about the, lots of people trying to build gigawatts of data center, right? Gigawatts sounds a lot, but if you break it down, right, in the next couple of years, people are talking about building 600 kilowatts per rack, or even 1 megawatts per rack in the data center. Okay, so 5 gigawatts basically allows you to build, let's say, if a rack consumes 1 megawatts, you're talking about 5,000 megawatts. Okay, 5,000 racks. That basically consumes 5 gigawatts, right? So that's the math. 5 gigawatts sounds a lot, but that in reality is just translating to 5,000 1 megawatt rack in the next 2-3 years.
Wild.
So, and sorry, that give you another number. This rack this per rack costs millions, right? It's a few $1 million per rack. So if you build 5,000 racks, each rack costs you, let's say, $3 million. You can do the math. How much money is it going to cost, right?
Wild. Wild.
Yeah, the scale just, I think if you think about it, actually makes sense, right? Today it sounds this gigantic number, but down the road, if you think about looking back a few years, it may not be that big anymore, because AI is basically going to be the engine for the global economy for years to come, right? Everything is going to be running on AI, this intelligence, everything, right? So
as someone in one of these leadership positions, how do you balance pushing technology while staying grounded with what customers actually need today?
I think as with any time in history, right? From the .com to the mobile to the cloud, to today, right? This AI era we are in. You have to stay close to the customer, right? You have to understand what they are trying to achieve, understand their use case, and basically, delight customers, and that's basically, again, that's how you win and how you sustain a business going forward, right? So that being said, I think, again, if we can learn from history, when new technology is transforming the entire world, the entire economy, sometimes you just have to jump in. You have to jump in, embrace and adopt, and because you want to survive, right? Because every technology wave, there will be consolidations, there will be reshuffling, if you will. I think survival is something should be on every business leader's mind. It's not about ROI. It's not about why you should invest. It should be how do you want to survive this technology wave, not be replaced by AI. You want to be enhanced by AI. So those are the conversations we have with our customers.
I'm going to go back to liquid cooling, because this is such a buzzword topic, and it's a concept that even I've gotten a little curious about and tried to do some technical reading on it, but it does get deep. So it's a buzzword in sustainability. It's a buzzword in performance. We understand the energy and heat that's going to be created by the demand for this type of technology. So what are real world impact, and what are companies doing to make this shift possible?
Yeah, so this actually is a big question, right? It's a big scope, because it going back to your earlier discussion, right? This takes the whole ecosystem to make it happen, right? So if you think about liquid cooling, there's a few angles. First of all, going back to our discussion about this transformer-based model that's basically driving this demand, that's going to continue unless there's something better comes around that become more efficient, right? So as people trying to meet that compute demand by delivering more powerful chips, that just consumes more energy. Okay, so that's why in the past, the TDP of a chip is like 100, maybe 200, but now people are talking about potentially 2,000, right? Sometime in the very near future, 2,000 watts per chip. Once you put multiple chips into a compute tray, then you put multiple compute trays in a rack. That changes many things. It changes how you're going to deliver this compute infrastructure in the data center. And also begs the question, is your current data center ready for this type of new compute? The answer is most data centers today is not. Okay, that's why you see a huge build out for new data centers going on today. There's billions of investment going into the data center build out over the past year or two. That trend we believe is going to continue, right? So this, I think there's many different angles that basically is driving change, needs to be changed. The data center today, most of the data center today is still per rack power density is like 15 kilowatts. That's basically the one AI server that Supermicro can deliver. Today, we're going to, let's say, 100 kilowatts, maybe 200 kilowatts rack. But down the road, you're going to talk about, 600 kilowatts, 1 million kilowatt, 1 megawatts, rack. But once you put more and more compute and the liquid cooling into the rack becomes so heavy. So the current data center, the floor needs to be redesigned and reinforced in order to make it happen. So the liquid cooling, again, is a necessity. Because without liquid cooling, it simply cannot, air cooling cannot cool the chips and the servers anymore. So liquid cooling is, I think is going forward, is going to become more and more popular and adopted. Going back to Supermicro.
So what you're saying is I should invest in liquid cooling.
Exactly. Actually, our CEO Charles actually started talking about liquid cooling a few years ago, right? Last year, he predicted that the new data center deployment, at least 30%, will be liquid cooled, new data center. Okay, we see that happening. The reason that the liquid cooling is not being adopted as quickly, I guess, as people would have liked, is because the data center is not liquid cooling ready. So so everything have to come in place in order to make this happen. But we believe liquid cooling will be adopted more and more, especially for large scale deployment. They all liquid cooled. I mean, at least 80-90% is liquid cooled.
I have one last question for you today. And, I think it's better not to be surprised at our daily changes in our world right now. It's probably better to just take in the information, go, okay, and move on with everything that's rapidly evolving. But has there been something in the last year that has truly surprised you in AI and the infrastructure landscape?
I think the pace of innovation is so fast. I actually expect surprises every day nowadays. That being said, I give you a light-hearted answer. A few years ago, this data center, infrastructure is such a boring topic. Okay, nobody cares about it, right? Nobody cares. It's this bunch of geeks, tinkering with hardware, in back office, just boring. But I would say over the past year or two, this has changed. This data center infrastructure, AI infrastructure, have become the forefront of many discussions, right? Not only business discussions, but even at dinner table, right? People talking about AI infrastructure, GPU deployment. For example, we deployed 100,000 liquid-cooled GPUs last year alone. Okay, it's a huge accomplishment. There's lots of people know about this, and when I talk to customers, they always, is marvel at this, the speed that we deploy those liquid-cooled data centers. So it's become such a sexy topic. It's no longer boring. I would say that's the biggest surprise. That's the biggest surprise, I think, from last year. I'm working a sexy business now.
Yeah. We're going to get a t-shirt made for you that says like data centers or like
Yes,
ask me about my data centers.
There's so much fun stuff in the data centers. It's very exciting topics nowadays.
I'm thrilled for you, Ray. That's great. That's awesome. I want to thank you so much for coming on today. This was such a fascinating discussion, and I really enjoyed the connectivity that you brought together about how these industries all have to work together and how we need to be using all of these elements in the same way that the tree grows in the forest that your boss walked up and saw and walked past every single day. Thank you so much for being on the show. This was Ray Pang. Again, my name is Heather McGuigan. I am your host. And thank you for watching another amazing episode of Intel on AI. Thanks, Ray.
Visit intel.com/AI to learn more.